right, so section 3.3, polynomial zeros and factors. So we're going to start out doing some similar stuff to what we did last week. Kind of help get that going. We're going to factor a polynomial completely, so as far as it will go. And if we're going to do that, we got to use that idea that we talked about last week, that if k is a 0, then x minus k is a factor. So that whole idea that we used last week when we were doing some synthetic division with polynomials. So let's start with one. Maybe it's 3x to the 5th minus 2x to the 4th plus x to the 3rd minus 8x squared plus 5x plus 1. And they're going to give us the first factor, and it's x minus 1. Okay? They'll say x minus 1 is a factor. The instructions may say that the factor is listed after the problem. So it's a factor, and we're going to take that and we're going to use it in synthetic division to start breaking this polynomial down out of that. So, the first step you're going to set up is your synthetic division with this problem. So we're going 3, -2, 1, -8, 5, 1. I'm going to set x minus 1 equal to 0 in order to get the number that goes on the shelf. So remember doing this last week. We started doing that. So we're just verifying that that's a factor. Just reviewing that skill here. And then we'll get into factoring it completely in just a little bit. All right. So first step, drop that 3 down, multiply. And then add. Multiply. Add. Multiply. 2 times 1 is 2. It's -6, multiply, -6, multiply, it's -1. +1 plus -1 is 0. That right there tells me that x minus 1 is a factor. So x minus 1 is a factor. If it tells you something is a factor and you don't get a 0 in that last spot, something went wrong. You may have missed, a lot of things could happen there. You could have missed a sign somewhere, may have mismultiplied or misadded, or it could be the fact that if there was a missing piece, you didn't put a 0 in that place. Remember, if there's a missing power of x, you got to put a 0 in its place. There wasn't any missing for this problem, but those are things that could cause it not to get a 0 in that spot if they already told you that something was a factor. Okay. All right, so what does that do to this problem? It takes it and starts factoring it. So you get this factor of at x minus 1, and then what's left over, this stuff right here, is 3x to the 4th power plus x to the 3rd power. So I'm taking the coefficients here, and I'm just going 1 power down from what I started with. So I started with x to the 5th. So that becomes x to the 4th. X to the 3rd, x squared, plain x, and then a number. So that'd be plus 2x squared minus 6x, and then minus 1. So that's the beginnings of what we're going to be doing today, is taking a factor given to us, and we're breaking down the polynomial. We're just breaking it down one step on this problem. We're going to eventually get to breaking it down further and further out of that, okay? So that's the beginnings of that. So, but in order to be able to do that, you've got to get a 0 as that remainder. If you don't get a 0, then it won't work that way. Okay. So let's do another one just to make sure we're on track with our synthetic division. Long division, we did that. That's a little tougher, but you don't use it quite as much There's really only a couple of times in an algebra class that you're going to use long division with polynomials. But it's a skill you kind of need to know, especially for some things that we're going to do in 110. So now this one, they give us that factor here on the end. They're saying x minus 1 again, and they want us to verify if that is a factor of this polynomial. So we're just going to set up the same thing. 2, and then this one is missing the x cubed, so we're going to put a 0 in that place. So make sure that you're paying attention to that issue that could come up. And then we still know that x minus 1 equals 0 is going to give us a positive 1 that we'll put on the shelf. And then we're running our synthetic through. So drop the 2 down, and then you start rolling. 2 times 1 is 2. 0 plus 2 is 2. 2 times 1 is 2. And add is 5. 5 times 1 is 5. There's a 0. It's not in the right spot. 0 times 1 is 0. We get a 7 there. What does that tell us about x minus 1? Not a factor. Yeah, that's what it tells us, okay? Now, that's good. As we're trying to break down these polynomials, what we're building up to in this section is being able to start with just a polynomial and go from nothing given to us. So everything so far, they've given us something to start with. So we're building up into what happens if we don't get anything. So we got to be able to recognize that if that happens, then we know, hey, that's not a factor. I got to go try something else if I'm trying to break that polynomial down. So we're just practicing that synthetic division and whether or not something is a factor. If it's a factor, it's going to have a 0 in that remainder spot. If it's not a factor, it's going to have anything else other than 0. It doesn't have to be any kind of special number, just anything else. All right. All right. So let's get into actually factoring a polynomial completely. So we're going to still get some information here that's going to get us started, and then we're going to take that and break down the polynomial as far as we can so that we can start working with it a little bit. So this is the factor completely. Let's do a couple of problems of that. Factoring completely. So this example C, let's take a polynomial. 6x to the third plus 19x squared plus 2x minus 3. And they tell us that x plus 3 is a factor. Okay. They told us it's a factor. That means that when we do the synthetic division for this, we should get a 0 in the remainder spot. Okay. That's what should happen here. So when I set that up with synthetic, 6, 19, 2, negative 3, and then I take the x plus 3, set it equal to 0, and subtract 3, and I'm going to get negative 3 goes on the shelf. Okay, so negative 3 on the shelf, and then we work our synthetic division. So drop the 6 down, multiply. That works out pretty nice. Negative 3. Negative 1 times negative 3 is positive 3. And there's that 0 that they told me I should get as the remainder. Okay, because they told me it is a factor. Then I know I got that. So what that does is it takes this polynomial and gets us the factor x plus 3. And then the part that's left here is taking that power down by 1. So we started with x cubed in the original problem. So that means this red line here is going to be x squared at the beginning. So 6x squared plus x minus 1. So that's taking that and factoring it using the synthetic division to get it started. Now, here, this part, we could factor a little bit further because it's a quadratic, and that's where we use that x method for factoring. Okay? Remember, to do that x method of factoring, we're going to take the number that's in the front times the numbers in the back. So 6 times negative 1 is negative 6, and it's got to add to be positive 1. That positive 1 is coming from this number in the middle. Okay. So 6 times negative 1. That's how I got negative 6 in the top. The 1 in the bottom is the one that's in the middle. Okay. So we need two numbers that multiply to be -6 and add to be +1. Well, I'm thinking 2 times 3, and to add to be positive and multiply to be negative, one of them's got to be positive, one's got to be negative. If I make the 2 negative, that'll be -2 times 3 is -6. -2 plus 3, hey, that's +1. That's the right way, okay? And then I can't use the shortcut for factoring on this one because it's got a number in front of x squared. So I write it out 6x squared plus 3x minus 2x minus 1. So I just wrote it in that order so that I got an easy common denominator or a common factor between 6x squared and 3x. That's the only reason. It doesn't matter what order you put those middle pieces in. So remember, those middle pieces come from the x there. And then we're grouping first two together, last two together. So GCF of 6x squared and 3x would be 3x. That'd be 2x plus 1. And then 2x and 1 only have 1 in common. And because this is a negative, we're going to pull out a -1. And that'll give us 2x plus 1 in parentheses. So technically, this is what that step has in it. You can, if you can just remember, hey, I got to bring that x plus 3 down with me at the end. Then the factors are going to be 2x plus 1, the ones that match. That's that one. And then the stuff in front is the other one, 3x minus 1. And that is that polynomial factored as far as it'll go. That's completely factored. And you might hear that called factored form. Another name for that is intercept form. Because if you set each one of those factors equal to 0, you'll find the x-intercepts for that polynomial. So we should, but factoring it all the way as far as it will go, what we're after here. Okay. And sometimes that quadratic will factor, sometimes it won't. And we've got to check it to see. So let's look at another problem. Example D. F of x. Here's our function x cubed plus 4x squared minus 5. And they're telling us x minus 1 is a factor. So they gave us a factor again. And we're going to take that and factor this polynomial as far as it'll go. Okay. So set up our synthetic 1, 4, 0, -5. Because we had the missing plain x. So we put that 0 in there. What goes on the shelf for this one? Is it +1 or -1?
-1.
Remember, we got to set x minus 1 equal to 0. And then when I move it, it's going to be +1 that goes up there. Be careful of that. That's a easy thing to positive and negative signs, not something that's going to be nice to you if you miss that part, because you would notice it when you did the synthetic. If you put a -1 up there, you wouldn't get a 0 in that remainder spot. So be careful of that. Okay. Drop the 1 and then do your synthetic. 1 times 1 is 1. 4 plus 1 is 5. 5 times 1 is 5. 0 plus 5 is 5. 5 times 1 is 5 again. And -5 plus 5. There's the 0 in the remainder spot. So that means they told me it was a factor. I verified it with synthetic. And that also helps me in factoring this polynomial, that I know x minus 1 is a factor. And then this part right here gets me x squared plus 5x plus 5. Okay. What I'm going to do is I'm going to try to factor this quadratic here, it's quadratic because it's got x squared as the biggest piece, using that x method. That's, 1 times 5 is 5. Is there anything that multiplies to be 5 and adds to be 5? Well, 5 is prime, so it's only 5 times 1 is the only option I have. 5 times 1 is 5, but 5 plus 1 is 6. It doesn't work. So it won't factor any further. This is the completely factored form of that because the x doesn't work. Okay, that can happen, and we're going to address how to solve if that does happen and all that stuff. But, so getting the factored form, you're going to use the factor they gave you and then try to break down the quadratic that's left over. Okay. All right. We're going to get some more practice with that as we're doing the next thing too. So you're not going away from this. The next idea is to factor given a 0. So instead of being given a factor, they're going to give us a 0 of the polynomial or an x-intercept, same thing. Okay, they might call it a 0, they may call it an x-intercept. Some of the older textbooks would call it a root of the polynomial. So it's the same, all those words mean the same thing. 0, x-intercept, root. You might say solution, you might hear that as well. All of those are the same thing, okay? They are the exact same thing. So here, if we're given a polynomial, let's say it's f of x is equal to 2x to the third power minus, 3x squared minus 5x plus 6. And then they tell us that k equals 1 is a 0. Okay? They're telling us the 0. That shortens it up for us a little bit when we do our synthetic. We don't have to go hunting for what goes on the shelf. This is the number that goes on the shelf. Straight up 1 right there. You don't change the sign or anything. They give you a 0, take what they give you. They give you a factor, you got to solve it. Okay, so be careful of that. 2, -3, -5, and 6. So I'm just setting up my synthetic division the exact same way I've done the last 4 examples. Nothing's changed here. The only difference is how they gave me what to start with. So then I take that and I just drop the 2 down and work my synthetic. 2 times 1 is 2. -3 plus 2 is -1. -1 times 1 is -1. It's -6. When you add that together, -6 times 1 is -6. And what do you know? I get a 0 in the remainder spot, which is what I thought would happen, or what should happen when they tell me something is a 0. Now, what does that give us? It gives us this quadratic 2x squared minus x minus 6. What was the factor that came with this 0? What's the factor that 1 is a 0 with? What was it up here on the previous example? It was x minus 1. So we know x minus 1 goes with that 0. That's the factor that goes with it. So it's just changing the sign. It's really all it's doing. If it's a positive one that they tell me is a 0, x minus 1 is the factor. If it's a negative that they tell me is the 0, it's a x plus that number. Okay. All right. Now, we got to see if we can factor this polynomial a little further. Well, that's a quadratic. It's got 3 terms. So I'm going to take that and do the x method with it. So 2 times -6 is -12. Add to be -1. -6 and 2. That multiplies to be -12, but it adds to be -4. So that's not right. -3 and 4. That multiplies to be -12, but it adds to be +1. Hey, that's real close. I'm going to swap the signs. It's -4 and 3. That does multiply to be -12 and add to be -1. So, and again, I can't use the shortcut here because I have a number in front of x squared. So I'm going to have 2x squared minus 4x plus 3x minus 6. And I'm going to group those together. First two, second two. Got x minus 1. And then we're going to factor out the GCF of 2x squared and -4x. It'd be 2x. And leave us x minus 2. And then the GCF of 3x minus 6 would be +3. So that gets us to the factored form, x minus 1. That's the one they told us about. And then we've got the matching piece, the x minus 2. And then we've got 2x plus 3 as the stuff in front's the last factor. That's the factored form. Okay. If you can get to the factored form, that's going to make the next step that we'll go to easier. Okay. If you can work toward getting to factored form, the next thing is easier. Okay. If you've already got factored form. All right. Now, let's go ahead and kind of dive into the next thing, which is actually solving. Okay. So I'm going to take this same example and we're going to solve it. So we're going to solve example E. Okay. So original problem was the 2x to the third, 2x cubed minus 3x squared minus 5x plus 6. And they told us that k equals 1 is a 0. We did all that work and we got it to the factored form of x minus 1, x minus 2, and 2x plus 3. Okay, we did all that work through synthetic division from the 0 they gave us to begin with, and then doing the x method for factoring on the quadratic that we had left. So we did all that work. So that's kind of the steps we're going to go through here. Now, in order to solve that, solving it means finding the zeros. Find the zeros. Well, zeros occur when the whole problem is equal to 0. So x minus 1 parentheses, x minus 2 parentheses, 2x plus 3 equals 0. Okay, we're setting the problem equal to 0. Set equation equal to 0. That's what we're doing there. Got that factored form, factored it as far as we could, and we set that factored form equal to 0. Then we just set the 0 product property that we talked about back when we did quadratics, said that if you multiply a few things together and it equals 0, then at least one of them is 0. And we took the worst case scenario is what if all of them are 0? And that's what we're going to take here. Is we're going to take each factor, x minus 1 equals 0, x minus 2 equals 0, 2x plus 3 equals 0. And we're going to solve all of those. Plus 1, x equals 1. We should know that one already exists because that's the one they gave us. That x equals 1 is a 0 of the polynomial. So we know 1 should be one of our answers. This one, add 2. X equals 2 is one of our answers. Third one's a little tougher to solve, but not too bad. It's a lot easier than the other stuff we've been doing. Divide by 2. -3/2. We had 3 solutions to that problem. What was the highest power on the original problem? it was 3. Okay, the highest exponent was 3. We found 3 answers. That goes together. Okay, whatever your degree is, that's how many answers you should be finding. Now I want to show you how does this relate to the graph of that polynomial. So with the graphing calculator, you can verify these things. So I've cleared out everything, there, and I'm just typing in that equation. 2x raised to the third power minus 3x squared minus 5x plus 6. That was the original problem, and I'm hitting graph. Notice how many times does it cross the x-axis? It crosses it 1, 2, 3 times. That means I should have 3 real solutions. Okay. Where are they? Where's it crossing at? Well, right here at this spot, right there. I don't know if you can see my mouse running around there. That's at positive 1. If I hit trace and 1, I get a y value of 0. That's a 0 of the polynomial. I got one of my answers was 1, right? The other answer, one of the other answers was 2. So if I trace 2, hey, there's y equals 0. That's another answer. That third answer that I got was negative 3 over 2. That looks like what this is on the left there. I'm going to hit trace, negative 3 over 2, enter. Hey, what do you know? It is. Okay, so the relationship between the graph and the zeros we find are where it's crossing the x-axis. The only time that is interrupted is if we have a complex solution out of that. Complex solutions don't cross the x-axis. Real solutions cross the x-axis. Complex ones don't. Okay, so we'll see that as we do some more examples here. It's not unheard of here. All right, let's look at another one. Let's say we had this polynomial, x to the third plus 4x squared minus 5. And they tell us x equals 1 is a 0. So just saying that here's a 0 of that polynomial. Now, this is a problem. We've actually already done this problem before, but we're going to go through all the steps here. So first step, set up your synthetic. Put the 1 on the shelf, 1, 4, 0, negative 5. Putting a 0 in there because we had the missing plain x term. Run synthetic with that, and I better get a 0 in that spot over there. If I don't, something went wrong. Okay. 1. And yeah, I do get a 0 there. Okay. So that tells me that I've got the factors x minus 1, because remember, that's the factor that goes with x equaling 1 is x minus 1. If it's x equals negative 1, it'd be x plus 1. Always the opposite. And then we've got x squared plus 5x plus 5 there. And we tried to factor this earlier when we were doing this problem. Example was, example D is the one that this was. We tried to factor this, multiply to be 5 and add to be 5, and we found out it doesn't factor. All right. So what does that tell us about solving this thing? Well, the way of solving it is exactly the same. We're setting each factor, we're setting the whole thing equal to 0, and then we set each factor equal to 0. Okay. Well, this one is the easy one. We already knew that one, x equals 1. This one is not quite as easy because it doesn't factor. So we've got to do it a different way. How do we do a trinomial if it won't factor? We use that quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. That's that formula that we talked about with quadratics, the quadratic formula is what that is. And so we're going to plug all that stuff in and then get the solutions based on that. So negative b would be negative 5 plus or minus b squared minus 4ac. So that's 5 squared minus 4 times 1 times 5. That's the discriminant. And then 2 times 1. Okay. So I'm going to get a little help here with the calculator. Parentheses 5 squared minus 4 times 1 times 5. Let's see. So I get a 5 underneath the square root. So negative 5 plus or minus the square root of 5 over 2. And square root of 5 doesn't simplify any. Okay, so that tells us that I have two solutions. I got negative 5 plus the square root of 5 over 2, and I have negative 5 minus the square root of 5 over 2. I have 1, 2, 3 solutions. The highest power in the original problem, 3. That goes together. Remember the degree, the highest exponent in the problem, and how many answers you find goes together. Okay. Now, how can we verify that with the graph? You still can. Okay. So if I go to my graph, y equals, clear out the other one I had. I'm going to type in this new equation, x raised to the third plus 4x squared minus 5. And I hit graph. I see it crossing the x-axis at 3 places. I got 3 answers that were real solutions that didn't have an I in them, so there wasn't a complex. So that tells me there should be 3. These 3, I hope, match up to the ones I found. Well, right here on the right, there's that 1. So if I hit trace 1, I get a 0. That's the one they told me about. That's a give me. Okay. The other 2 are at weird spots. They're not right on anything. So I'm thinking they should be at these 2 values here. Okay, so I can actually check those with the calculator. So when I type that in, I hit trace, and then I got to be careful as I type that in. So I got to put the top part in parentheses. So negative 5 plus the square root of 5, close those parentheses, divided by 2. Okay, so got to type it in that way. Hit enter. Hey, it converts it to a decimal when it displays it. But hey, the y value is 0, so we know that's correct. And then I'm going to do the same thing for parentheses negative 5 minus the square root of 5. Close those parentheses up. All that divided by 2. And there, hey, it found the other one. That's verifying that those are correct. Now, if it's crossing at a nice spot, that's going to be helpful later on. These that are in between, not always going to be. I don't think any of us could have took a stab at it and guessed negative 5 plus or minus the square root of 5 over 2 out of that. But helpful to relate that graph back to the answers that we're finding. Okay, that's what we're trying to do here, is relate those answers back. All right, let's do another one of those. Let's say our polynomial is this: 4x to the third plus 6x squared minus 2x minus 1. And x equals 1/2 is a 0. Throw a fraction in there, make it a little bit more fun, right? Everybody loves fractions. All right, now, same idea. We're going to start with our synthetic. We got a 1/2 on the shelf this time, so it's a fraction up there. Got a little better. And then we're 4, 6, negative 2, negative 1. Just putting those spots in there. Don't have any missing pieces here, so easy to put in. So drop the 4 down, go to work. 4 times a half is 2. 6 plus 2 is 8. Half of 8 is 4. Negative 2 plus 4 is 2. Half of 2 is 1. And there I get my 0 in my remainder spot. So I'm verifying that x equals 1/2 is a 0 of that. So that gives me a little hope. X minus 1/2, 4x squared plus 8x plus 2 is what's left over there. Now, I'm going to try to factor that if I can. Well, what do you know that 4, 8, and 2 are all divisible by? They're all divisible by 2, so I can make that a little easier by pulling a 2 out, and I'm just going to put it out in the front of everything. Okay? And that'll leave me 2x squared plus 4x plus 1. So that's the GCF step of factoring. GCF of the whole problem was that. And then I'm going to look to see if I can do the X method. 2 times 1 is 2. Add to be 4. 2 and 1 are my only options, and that only adds to be 3. So it doesn't factor again. So that tells me, hey, I've got to do the work to do quadratic formula for that. And you don't have to go through. You've already done the work to verify that x equals 1/2. So we know that that's there. And we're setting 2x squared plus 4x plus 1 equal to 0. This 2 that's hanging out here on the front doesn't have a letter on it, so it just kind of goes away when we're trying to solve here. It doesn't affect the problem. If it had an x on it, it would affect the problem, and it would have to set it equal to 0. But if you set 2 equal to 0, we know that goes. It doesn't exist. 2 doesn't equal 0, so you just throw that part away. Okay. Now we're going to do quadratic formula here. X equals negative b, so that'd be negative 4 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. All right. So we have negative 4 plus or minus, and let's find out what's underneath that square root. So I'm going to work out the discriminant here. 4 squared minus 4 times 2 times 1. My discriminant is the number 8. And on the bottom, I've got 4. So I've got to simplify that 8 under the radical. I didn't have to do that on the previous problem because it was a prime number, and I knew I didn't have to do that. So 4 and 2, 2 and 2. Got a pair of 2's. So that's going to give me x equals negative 4 plus or minus 2 square root of 2 over 4. I can simplify this answer a little bit because all 3 of these numbers, notice I didn't include the number that's under the radical. You can't do anything with it. Only the numbers on the outside. All of those are even, so I'm just going to divide them all by 2. It'll be negative 2 plus or minus 1 square root of 2 over 2. Okay. So I've got 3 answers here. Negative 2 plus the square root of 2 over 2. Negative 2 minus the square root of 2 over 2. And then the 1/2 that they had at the beginning out of that. So that's my 3 answers for the cubic or the third power equation that I started with. Out of that. So using the quadratic formula to find those last 2 there is the key to that problem. All right, and we could verify that with the graph if we need to. If we graph the original problem, 4x to the third plus 6x squared minus 2x minus 1. We graph that. We see it crossing in 3 spots. If we hit trace, the 1/2, there's it. That's the one they told us about. It's not exciting. And then we do the other ones, -2 plus the square root of 2. Oops, put my 2 in there. Over 2. There's that one. And then trace parentheses, -2 minus the square root of 2 over 2. And there's the other one. So we verifying those with the graph. That's going to be handy as we kind of transition into the next thing. All right. So the next thing that we're going to do is employ this thing called the rational zeros theorem. Where it's handy is when they don't give us anything except for the problem. They give us a polynomial and say, find the zeros. That's all they do. They don't tell us anything about a zero or a factor of that. So that can be daunting, but because I've already been doing a lot of stuff relating the graph to the polynomial, that's the key to this. And so let's talk about what's called the rational zeros theorem. Handwriting is not good today. The rational zeros theorem. We'll write it out and then explain what it's talking about. Is a all right. If P over Q is a rational number and a zero of a polynomial, we'll call that polynomial f of x. It really doesn't matter what you call it. Then the number on top, P, is a factor of the constant term from the polynomial. So like the number at the end, okay? And Q is a factor of the leading coefficient, the number in the front, okay? So rational zeros, what we're going to do is we're going to use those to help us make an educated guess at a zero for the polynomial, okay? We're going to make a list of all the possible rational zeros, and that narrows it down from every number in the world into a list, a small list of numbers that's easy to go through. Okay, and then we're going to use the calculator and the graph to help us a little bit too. So let's take a polynomial and let's start talking about the rational zeros, and then we're going to go through the whole gamut with it. We're going to do the rational zeros. We're going to get that list. Then we're going to take those and use the graph and synthetic division and break that polynomial down as far as it'll go and get the zeros for it. So let's just take that. I don't know what letter am I on here. I. All right. So here's our polynomial. F of x equals 6x to the fourth plus 7x cubed minus 12x squared minus 3x plus 2. All right. So when you're talking about rational zeros, before you start doing that, first thing you want to do is look to see if there's a number that will divide into everybody, like the greatest common factor for the whole problem. This one, the 7 messes that up, and the 3 because they're prime, and those don't go into all the other numbers. Okay, so if everything was divisible by 2, you could divide everybody by 2 to make the problem smaller. So we get smaller numbers out of that. All right. So here's what we're dealing with here. We want to get the possible rational zeros. And I'll go ahead and tell you, every time I've given the final for 100, I've been teaching 100 for 4 years now, I guess. This is at least one of these is on the final exam where you just list the possible rational zeros. Where you just make this list. You don't have to do anything else with the problem, but make this list. So making the list is an important skill. It's also helpful when you actually do have to solve it. So be able to make this list. A lot of people try to get by without making the list, and they'll miss that give me problem on the final exam. And you don't want to miss any give me problems on the final. I promise you that, because there's enough hard ones on there. You want to get all the easy ones you can. So this is an easy one to get. So we're going to make I call it the P over Q list. It's the possible rational zeros, the P over Q list. All right. All right, P over Q. P for this problem is the constant term. The constant term is 2. It's that number down here on the end. Q is the leading coefficient. That's the number in front of the highest power of x, so that's the 6. Okay? So we want the factors of those. So what are the factors of 2? 1 and 2. What are the factors of 6? Well, 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6. So you're listing out all of the things that would divide into that number evenly. That's what it means by listing out the factors. Now, that's how you start making the list. The actual list is this set of numbers. And here's how you build that set. You take the factors that are on top. 1. Start with it. 1 divided by 1, 1. And then take the next factor. 2 divided by 1, 2. Okay? So I've used up that one. Then take the top factor. 1 divided by 2. That's 1/2. What's 2 divided by 2? 1. I've already got that listed. I don't have to write it again. Okay? So I've used up the 2. Then I divide everybody on the top by the next factor. 1 divided by 3, 1/3. 2 divided by 3, 2/3. I've used up the 3. 1 divided by 6, 1/6. 2 divided by 6, that reduces to 1/3. I've already got 1/3 listed. That's my list of possible rational zeros for this. Okay. Now we've taken the possible zeros for this polynomial, and instead of every number in the world, we've narrowed it down to a list of 1, 2, 3, 4, 5, 6, and positive or negative on each of those. So only 12 possible numbers out of that. So back when I was in high school and we started learning this stuff, or when I took college algebra, we didn't have the luxury of the graphing calculator. We had to just make a guess and pick one to try in synthetic division. And if it worked, great. If it didn't, start over. And that's how we had to do it. You guys have the graphing calculator in hand, so it is got some help to shortcut us on that. Take a shortcut, and everybody likes a shortcut when there's something like that going on. So this is the list of possible rational zeros. So make sure we're going to do that on each problem we're doing the rest of the day. So possible rational zeros. That's that list. Okay. What we're looking for is, that means if this thing has a 0 that crosses the x-axis and it's a rational number, as in it doesn't have a square root in it or anything like the last couple examples had, it's going to be one of these numbers. It has to be. That's what the rational zeros theorem says. Okay, so the next thing we'll do is we're going to graph f of x. Okay, so we're going to take this polynomial and we're going to graph it on our calculator. That's the next step you want to do. So go to y equals, clear that one out, and graph this polynomial. 6x to the fourth plus 7x to the third minus 12x squared minus 3x and then plus 2. Okay, so just typing in that original polynomial and we're hitting graph, and we're going to see it crossing the x-axis in 1, 2, 3, 4 places. So that means we have 4 real solutions to this problem. Well, let's look for a good one that's a decent number. Well, if I just read this left to right, I see it crossing the x-axis right there at what I think is -2. You know, it may be a little bit to the left of -2, maybe to the right of -2. I can verify that by hitting trace and then -2. Boom. That tells me that is a 0 of the polynomial. Okay, so that tells me, hey, is -2 in my list of P over Q's? Plus or minus, there's a 2 in there, so that's the -2. So it's in the list. Okay, that's how I knew that it was going to be a possibility. Okay, so what I'm going to do is then take that and do synthetic division with the -2, because I know, because I just verified it on the graph, that -2 is a 0 of this polynomial. So I know when I do synthetic division, 6, 7, -12, -3, 2, I should be getting a 0 in that spot over there. That's what I know. All right. So drop the 6, multiply. And I got a 0 there. Okay. So that broke the polynomial down one step. And I've got 6x cubed minus 5x squared minus 2x plus 1. I don't have a lot of skills for factoring things that have x to the third power in them. Okay. So what I'm going to do is I'm going to do synthetic division again on this line and use another number from my P over Q list. So I go back to the graph. Okay. I'm looking for another place that it crosses the x-axis at a good spot. That one right there, the next one, if I read left to right, the next one looks like a fraction. I'd rather not do a fraction if I have a choice. The next one looks like a fraction. I'd rather not do a fraction if I have a choice. Well, hey, the last one there, that looks like +1. So I'm going to hit trace, +1, hit enter. Yes, it works. That's good. That means I can take that and use it for synthetic division. So I'm going to set up another synthetic division. Just taking this line and I'm putting a +1 on the shelf. I should be getting a 0 in the remainder spot. Okay. Drop the 6 down. And hey, what do you know? I did. I got a 0 in the remainder spot. So what I've done so far is I've found the zeros, -2, 1, and then I should have 2 more that I'm going to find. Okay. That's what I've found by doing this synthetic division. What I've also done is I've broken the polynomial down into a quadratic, that this is 6x squared plus x minus 1. I have a lot of tools for solving quadratics. I've got quadratic formula that I could do. I could try to factor this with the x method, which is the way I'm going to do this one. But I can solve that quadratic. So what I'm trying to do anytime I'm trying to solve a polynomial is break it down with synthetic division until it's an x squared problem. Once I get it to x squared, then I can do some other stuff. Okay, so it started as x to the fourth power. I had to do synthetic division twice to get it down to x squared. So that's, you kind of got to look at the highest power and then subtract 2 from it, and that tells you how many times you need to do synthetic division. All right, so I'm going to do X method for this one because it's an easy one to do it that way. 6 times -1 is -6. Add to be +1, be 3 and -2. So 6x squared plus 3x minus 2x minus 1 equals 0. And I'm going to group that. And then a -1. So I get 2 factors out of that. I get a 3x minus 1 and a 2x plus 1. One more space here. 2x plus 1, 3x minus 1 equals 0. And I'm going to take those factors and just set them equal to 0 and solve them. If the X method would not have worked on this one, I'd have just done quadratic formula. You could even just do quadratic formula automatically if you wanted to, because you know it's going to work no matter what. Quadratic formula always works. Factoring doesn't always work. And then I divide by 2, and there's my -1/2. And then I'm going to solve this one. Add 1. 3x equals 1. Divide by 3. X equals 1/3. So I get 4 answers out of this thing. I got the -2 and the +1 that I found by doing synthetic division, and then I get the -1/2 and the +1/3 that I found by factoring. Okay. If I go back to my graph, if I hit trace -1/2, that's that spot right there. If I trace 1/3, that's that spot over there. Okay. So the graph directly relates to that stuff. So you can check and sometimes take a little shortcut out of that. The P over Q list, though, is an important thing. It's going to be on the final. It's going to be on your Canvas quiz. Okay. It's going to be on the lab. I mean, it's just be able to make the P over Q list. We know that there are a little bit of shortcuts there because you have a graphing calculator, but it doesn't necessarily eliminate that rational zeros thing. So let's look at another one. Let's say let's just start with a polynomial. F of x is x cubed plus 5x squared plus 2x minus 8. Okay. And let's make the P over Q list again. So 8 and 1. Don't really worry about the negative sign on there. Just think about the number as the factors. What are the factors of 8? 1, 2, 4, and 8. Yeah. And then the factors of 1 is just 1, right? Plus or minus 1. So when we make our P over Q list, plus or minus, and then we're just dividing every one of these by 1, it's a lot easier on the P over Q list when that leading coefficient is a 1. It makes things so much quicker. Okay. And it also helps us because we know we don't have to deal with any fractions out of that. So that since that leading coefficient was a 1, it makes this easy to do. So we're going to set up synthetic division, and we got to figure out what goes on the shelf. So 1, 5, 2, -8. How do I find out what goes on this shelf here? I got a polynomial. We're trying to find the zeros of that polynomial, so we're trying to find where it crosses the x-axis. So I'm going to look at the graph of this polynomial. So I'm going to graph it. X to the third plus 5x squared plus 2x minus 8. Yeah, got all the signs right. hit graph. This one looks like it crosses at 3 really nice places. I know positive 1 there. That looks like -2. That looks like -4. All of those are in our list. I just need to pick one to start with. Okay. I think positive 1 would be easier than the negative ones. That just makes sense to me to use the positive 1 because it's an easier number to use than the negative ones. All right, so pull the 1 down, multiply, add, multiply, add, multiply. Hey, there's the 0 that I expected to be there. And then I've got a quadratic left because I started with an x cubed. I only had to do synthetic division 1 time to get it down to a quadratic. The quadratic I have is x squared plus 6x plus 8. I'm just setting it equal to 0. And I can factor that, I think. Multiply to be 8 and add to be 6. 4 times 2 is 8. 4 plus 2 is 6. So that's a pretty easy factor. I can take the shortcut because there's a 1 in front of the x squared. So my factors are x plus 4 and x plus 2. And then I just set each one of those factors equal to 0. Oops. Plus 2 equals 0. And solve them. So -4, -2. So x equals -4. X equals -2. And then I had x equals +1 is this guy that I used in synthetic division. Don't forget that one. Okay. I can go back and verify those with the graph. I just trace -4, trace -2, and that's the ones that we saw when we graphed that. Okay, so with the graph, if you hit trace -4, you should be getting a 0 back for y. -2 is the same thing. Okay. So the graph directly relating to the polynomial is key to this. All right. Okay. Let's take this one. F of x. X to the third power plus 3x to the second power plus 3x plus 1. This one is a pretty interesting one. Okay. Let's use P over Q list again. This was a quick P over Q list because it's 1 and 1. So that's just plus or minus 1. That's our P over Q. Positive or -1. Okay, one of those two. Okay, so set up our synthetic. 1, 3, 3, 1. And we need to find something that goes on the shelf. How do I find that? Graph the polynomial. Okay. So we're going to graph x cubed plus 3x squared plus 3x plus 1. So y equals, for that one out, x to the third plus 3x squared plus 3x plus 1. And see what's happening here. Huh. Well, this one looks like it only crosses the x-axis at that one spot. At -1. If I hit trace -1, well, that's the one I got to use. It's the only one I see, right? So -1 goes on my shelf. Drop a 1 down, multiply. Just go through the work. 2. And there's that 0 in the remainder spot, so I know that's right. That leaves me, I started with x cubed. Now I got an x squared. And set that equal to 0 and solve it. Okay. I'm a factor person. I like to factor it if it will. 1 times 1 is 1. I got to add to be 2. Well, hey, 1 times 1, 1 plus 1. That works. So my factors then are x plus 1 twice. I get the same factor set equal to 0. And when I solve that, I get -1 both times. In fact, I got -1 3 times. The one time I did it with synthetic division, and then I got it for both answers when I solved that quadratic. What that means is you have a 0, x equals -1, and it has what's called a multiplicity of 3. And a lot of times you'll see it abbreviated MULT 3. They'll write it like that. It just means it counts 3 times. Whatever number is after if the multiplicity is 2, that means that answer counts twice because it showed up as, the answer 3 different times. Okay, even though it only crossed in one spot. Well, it's crossing in one spot, and just happens to count 3 times out of that. All right, so see that kind of happening there. All right, let's look at this one. Say our function is this, x to the third minus x squared plus x minus 3. That's our polynomial. So again, P over Q list. This one's a little, not much more difficult. 3 and 1, so we got plus or minus 1, and 3 and plus or minus 1. So that means our P over Q list is just the numbers 1 and 3. Positive or negative 1 and 3. So there's our P over Q list, our possible rational zeros. Set up our synthetic. 1, -1, 1, -3. I made it so long. And then we need something to go on the shelf. So how do I get what goes on the shelf? I graph it. So go to y equals x to the third power. Oops. Start over. Minus x squared plus x minus 3. Graph. It's multiplied somewhere along the way here. That should be minus 5x in there. Sorry about that. I believe that's right. Let me change that. Minus 5x. Doesn't affect our P over Q list. It sure does affect the graph a whole lot. That's what it should be there. Should be a minus, or x cubed minus x squared minus 5x minus 3. Sorry about that. So I'm going to change that there to a minus 5. Give myself a little bit more space. All right. So I'm looking for where does that cross the x-axis in order to get started with this problem. So I just need to do synthetic division once, and then I can work with it from there. Hey, I've got -1 and then or a +3 is what it looks like it did. I'm going to verify that +3 because I think that's the one I want to use because it's a positive. Okay, so I'm going to use a +3 on the shelf. Drop down the 1, multiply. And there I get the 0 in there, and that works out great. And then I've got x squared plus 2x plus 1 equal to 0. So I got a quadratic there. And I'm going to factor that 1 and 2, 1 and 1, x plus 1, x plus 1. Hey, this is the same one that I had earlier. When I set those equal to 0, I get x equals -1 with a multiplicity of 2 because it counts twice. And then I get x equals 3 as my third solution to that. So far, everything we found has had real solutions. What if it had a complex mixed in there with it? Doesn't change how you do it very much at all, other than once you get to the quadratic part. All right, so let's look at this problem. Let's say we had x to the third, f of x equals x to the third minus 3x squared plus 4x minus 12. What letter are we on here? M. Yeah. There's our polynomial. And we want to solve that and find the zeros of that polynomial. So P over Q list, factors of 12, the factors of 1. So it's just the factors of 12 is all it's going to, anytime that's a 1 in the bottom, you know your P over Q list is just going to be the factors of that constant term. So what are the factors of 12? 1, 2, 3, 4, 6, and 12. All those numbers going to 12 evenly. So it's got to be some of those, or one of those at least. Okay. So we're going to set up synthetic. 1, -3, 4, -12. We need something to go on the shelf. Again, to find that, you're going to graph it. X to the third minus 3x squared plus 4x minus 12. I only see it crossing the x-axis in one spot. That means I only have one option. I'm going to hit trace. It looks like a +3. I'm hit trace 3. And that is the only place it crosses. So I'm going to hit a +3 on the shelf. And then run that through. And there I get that 0 as my remainder. So that tells me +3 is a solution to this, or a 0 of that polynomial, an x-intercept, a root, solution, all those the same thing. And then what I've got left here is I started with x cubed. So this becomes x squared plus 0x plus 4. So it's really just x squared plus 4 that I'm setting equal to 0. Because there's nothing in front of the plain x. It's a 0. So I can solve that a couple of different ways. One way is quadratic formula. The other way is just solve it by square roots. Square roots is the shortest way on this problem because I can just get the x squared by itself. I remember us doing that a couple of weeks, about a week and a half ago. So subtract 4. X squared is equal to -4. And then I take the square root of both sides, plus or minus on the side with a number. And the square root of 4 is 2, but because it's a negative 4, it's going to be 2i. I had one place where it crosses the x-axis. I should have 3 solutions because it's x cubed. Those other 2, one is positive 2i, the other one is negative 2i. Okay. You can't verify the complex ones with the graph, though. That's the bad part about it. But you can verify the real one. These others you could verify with synthetic division. You could work that out and see that it's there. But the complex doesn't change how you go about the problem. Just changes how your answers look and how the graph looks. Okay. Let's do another one. All right. Change the letter up. I've been doing f of x all day. So g of x. Just change x to the 4th power minus 7x cubed plus 18x squared minus 22x plus 12. All right, so I got an x to the 4th power problem. And remember, the whole goal here is to try to get down to a quadratic. So that tells me I need to do synthetic probably twice on this problem. Okay. Unless something, miraculous happens here, which I don't see that happen. So P over Q list, still 12 over 1. So the factors are 12. Plus or minus 1, 2, 3, 4, 6, and 12. Those are the possibilities. Again, we're going to use the graph to help us. 1, negative 7, 18, negative 22, and 12. So we need to graph that big polynomial and see where it crosses the x-axis. I think we need 2 places where it crosses the x-axis. So hopefully there are 2. So y equals, clear that out, x to the 4th minus 7x to the 3rd plus 18x squared minus 22x plus 12. All right, hit graph, and yes, I do see 2 places where it crosses the x-axis. Kind of a weird looking shape to that graph, but it works for us here. Looks like positive 2, so trace 2, and then positive 3, trace 3. Both of those. I'm going to use one of those at a time here. I'm going to start with the positive 2. Small. It doesn't matter which one you use first. Okay. And then run the synthetic division with that. So 1. There's that 0 in the remainder. So that tells us 2 is an answer to this. Now, I also know that 3 should be an answer to that. So I'm going to do synthetic division again using this line. So I'm just going to box in around it like that and use the 3. Okay. Use the 3 there. And then, so drop the 1 down and go to work. Negative 2, 6, 2, and there's 6. And there's that 0 in the remainder again. So I found that 2 and 3 are zeros to this thing. And I've broken this down into x squared minus 2x plus 2 equals 0. So I've taken the synthetic division twice to get an x to the 4th power down into a quadratic that I can either solve by factoring or quadratic formula. If I try factoring with this one, I need it to multiply to be 2 and add to be negative 2. That'd be -2 and -1, but that has to be -3. So that doesn't work. It won't factor. So that means I have to do the quadratic formula on this one. So I'm required to do that in order to solve it. So x equals -b plus or minus b squared minus 4ac. A is 1, c is 2, over 2 times a. And again, I want to use the calculator to help me get that discriminant. Parentheses, -2 squared minus 4 times a times c. I get a -4 under the square root. 2 plus or minus square root of -4 over 2. And we know we've already done the square root of -4 in the previous problem. That's 2i. And then all of these numbers are divisible by 2, so I'm going to divide them by 2. So that's going to be 1 plus or minus 1i, or just I there. So I get x equals 2, 3, 1 plus 2i, and 1 minus 2i. So that's 4 answers. The original problem had a 4 for the highest exponent. That goes together. I always should do that. On things you can't verify those complexes with the graph, other than just knowing, hey, if it only crosses twice and it's a fourth power problem, then it's got some complex solutions most likely out of that. All right. Okay. Let's talk about the last thing, which is building polynomials. So the last thing that we're going to talk about, well, next to the last thing. There's one last little thing that we'll talk about out of this. But, all right, building a polynomial. All right, so instructions would tell you, what letter on? That's in O. To find a polynomial of degree 3 that has zeros of -1, 2, and 4 with f of 1 equaling 3. And so a lot of information going on there. They tell you the zeros, and then they tell you another ordered pair out of that. So it's telling you, this is telling you x, and this is telling you a y value. That's what those are. Okay. So what we're going to do is we're going to take these zeros and build this polynomial. But we're going to put this a in there as the leading coefficient. We don't know what it is yet, but that's where that x and y is going to come into play. All right, so the first thing that I'm going to do is build the factors that go with the zeros. Okay, if -1 is a 0, what's the factor that goes with it? X what with the 1? It'll be the opposite, right? So +1, so +1. -1 has a factor of x plus 1. What would be the factor for the 2? X minus 2 is the opposite. The factor for the 4, x minus 4. Okay. Now, when you find A is totally up to you. I like to do it first because the math's a lot easier and at the beginning. Okay, so if I'm going to find A, that means I'm going to put an x in as 1 and a y as 3. So we're going to find A. That's the next thing we're going to do. So we set up with the factors, and we're going to find A. To find A, we're going to plug a 3 in for f of x. And everywhere there's an x, we're going to put a 1. So 1 plus 1, 1 minus 2, 1 minus 4. Okay. So that's going to be A times 2, negative 1, and negative 3. And then I'm just multiplying these numbers together. 2 times negative 1 times negative 3 would be positive 6. And then I'm going to solve for A by dividing by 6. So 1/2 is A. Okay. Now, that means I can go back to my polynomial and put a 1/2 in there. Next thing you want to do is multiply it out. So we're going to multiply out this polynomial. Okay. So we're going to take x plus 1, x minus 2, and x minus 4 and multiply them out. So it doesn't matter what order you do that in, but I'm going to do it in this order. I'm going to take these two first and multiply them together. So x minus 2 times x minus 4. So x times x is x squared, negative 4x, negative 2x, positive 8. Negative 4 times negative 2. And then I'm going to simplify that. The last thing that I'm going to do is multiply everybody by 1/2 by the A that I found. Okay, that's the very last step. Okay. So I'm going to multiply out x plus 1 times this x squared minus 6x plus 8. So that's going to be x times x squared is x cubed. X times negative 6x, negative 6x squared, plus 8x. And then I'm going to multiply 1 times x squared is positive 1x squared. 1 times negative 6x, negative 6x. 1 times 8 is 8. Okay. Remember stacking these up like we did back maybe second or third class meeting we had. We did that. So I'm just simplifying here. 1/2 parentheses x cubed minus 5x squared plus 2x plus 8. Last step, multiply everybody by that number in front. So just distribute the 1/2. 1/2 x to the third minus 5 over 2 x squared plus x plus 4. And there we finally built the polynomial that has those characteristics that they told me about. Okay. So they're going to give you the zeros and another ordered pair, and then you're going to build a polynomial out of that. We're going to do a few more of those. Get different situations that they could give us here. So, all right. Let's say we had zeros, negative 2 with a multiplicity of 2 and 3, and f of 2 equals 16. All right, so the multiplicity of 2 means that x, the 0 of -2 counts twice, okay? So when I start building my problem, the factor that goes with -2 is x plus 2. I'm going to put that down twice because it has a multiplicity of 2. Okay? If it said multiplicity of 3, I'd put it down 3 times. And then the other factor would be x minus 3 for the 0 of 3. I only put it once because it didn't say anything about multiplicity on it. So that's what we get. All right. Now we're going to find A next. So we're going to take this ordered pair that they gave us, f of 2 is equal to 16, and plug in 2 everywhere there's an x, and find out what A is. Okay. So that's going to be 4 times 4 times -1. That's going to be 16 negative with the A, and then an easy solve there. That'd be -1. A is -1. That's going to be make it easy at the end, very easy at the end. So that takes us back to the polynomial. We got a -1 in the front now, and then x plus 2, x plus 2, x minus 3. Again, it doesn't matter what order you choose to multiply this stuff out together. You can choose whatever order you want to. Since these two are the same, I'm just going to multiply them together first because it's squaring a binomial, and that's usually pretty easy to do. So I'm going to multiply that out together. X times x is x squared. X times 2 is 2x. And then I'm going to have another 2x, which would be 4x plus 4. So I can do that a little easier. Don't have to worry about the different numbers in there. I know it squares and doubles in the middle out of that. So I'm just multiplying that. I chose to multiply those two together first. It doesn't matter what order you do it in. Okay. Now I'm going to multiply the x plus 3 and this stuff. So it's going to be x times x squared is x cubed plus 4x squared plus 4x. And then I've got a -3 x squared. Oh, excuse me, -12x and a -12. And I'm going to simplify that. So x cubed plus x squared minus 8x minus 12. And then the last step's the easiest one is multiply by -1 because that's what we found A to be. -x cubed minus x squared plus 8x plus 12. And there's our polynomial that meets all those conditions that they gave us. How that? Tedious, not fun. A lot of places to make some errors, but it's you know, it doesn't get any you know, doesn't get much harder when you have rational zeros. Okay, where it gets a little tricky is when they give us a polynomial that has zeros of 3 and the square root of 5. And they go ahead and tell us A is equal to 1. So we'll go through the steps to find an A on this one. But they tell us A is equal to 1, so we don't have to worry about that. All right, now, what we get here is the fact that that's not all of the zeros to this polynomial. Anytime we had a square root in the answers for a polynomial, we also had, the other side of that square root. So there's a hidden one. The negative square root of 5 is hidden. They didn't tell us about it, but we should know it's there. Because remember, anytime we take a square root to solve a polynomial, we had that plus or minus in front of it. So if they tell you a positive square root of something is a 0, you know the negative is there too. If they say negative square root of 5 is an answer, you know the positive one is there as well. Okay, so those they're hidden from us, but we've got to know that they're there. So then this one's a little shorter because they tell us what A is. They tell us A is 1, so we don't have to do any work to solve it. So we just got to set up x minus 3, x minus the square root of 5, and then x plus the square root of 5. We're setting it up just same way with the factors. Nothing is changing there as far as that goes. Just the same old stuff. All right. Now, when you multiply this out, again, it technically doesn't matter what order you do it in, but it sure makes it a lot easier if you'll do the stuff that has the square roots together, because then the square roots will go away. So we don't have to deal with them anymore. Okay. So when I multiply that together, x times x is x squared plus x square root of 5 minus x square root of 5 minus the square root of 25, which we know the square root of 25 is really what? 5. So I'm just going to change that to a 5. Okay. And then we got the x minus 3. And I'm not even going to put that 1 out there anymore because I know it doesn't do anything. All right. So then I'm going to multiply or simplify that out because the square root of 5 stuff goes away. And that leaves me x squared minus 5, which is a little shorter problem to multiply than the ones we've previously done. X times x squared is x cubed minus 5x minus 3x squared plus 15. Last thing I need to do is just put it in order because that's the way they expect it to be, is in descending order. So that's what I would do, x cubed minus 3x squared minus 5x plus 15. If you're in doubt whether or not that is the correct polynomial, graph it. It should cross at the numbers they told you at the beginning. If it doesn't, something went wrong. Okay, so graphing it is the key there. But again, keep in mind, if they tell us that a square root is one of the solutions or the zeros, then the other, the opposite of that is also there. Okay. Same thing goes when we're talking about complex ones, and this is the hardest they get. Here's the ones with the complex, just because they're longer. Not that the math is that much harder, but it's longer. So let's say we had zeros of 3 and 2 minus I. A equals 1 again. We'll just use that. There's it. All right. Well, if 2 minus I is a 0, we also know that 2 plus I has to be a 0. That's the conjugate, the complex conjugate theorem is what that's called. It's the same idea that we know I came from the square root of a negative number, and it's got to have that plus or minus in front of it. So we know that came from that because we're dealing with a polynomial here. So when we set up our factors, we're going to set up x minus 3, and then we're also going to set up x minus 2 minus I, x minus 2 plus I. The change in sign is there on the I. Okay. Again, same idea as with the square roots. You want to do those two together first. And this is a little long, but it's doable. It's not pretty, but it's doable. So here's what happens. You just multiply x times x, x squared. X times negative 2 is negative 2x. X times positive I is plus ix, like that. So that's distributing the x. Then I'm going to distribute the negative 2. Okay, so that's negative 2 times x. Negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times I would be negative 2i. Okay, so I've distributed The x, I've distributed the -2. Now I've got to distribute the minus I. So I'm going to do that in a different color. Negative I times x would be negative ix. Negative I times -2 would be positive 2I. Negative I times positive I would be negative I squared. All of that is what that turned into. Okay. The beauty of it is it simplifies quite a bit. Okay. Your ix, you got a positive ix and a negative ix. They cancel each other out. We got a negative 2I and a positive 2I. They cancel each other out. And then that leaves just a few things left. Those two go together. So that'd be negative 4x. And then this and this go together. What does I squared? I remember I is the square root of -1. I squared turns into -1. So that's 4 minus -1 is what that turns into. So 4 minus a -1 would be 4 plus 1, which is 5. Not a whole lot of this. You're probably not going to see a problem like this one of this length on the final exam. You'll see more with the rational zeros on the final. But there is one of these on the Canvas quiz, and then in the lab there's one of these, a couple of these actually. So now all the I stuff cancels out. That's what I want you to notice. If it doesn't, then something went wrong. Okay? So then we're just going to multiply x times all of that. And this works out real nice here. X to the third minus 4x squared plus 5x, and then multiply by -3. So negative 3x squared minus or plus 12x minus 15. And I'm stacking that. And then the last line is just put it together. X cubed minus 7x squared plus 17x minus 15. We've got the polynomial built, given some zeros, and a little bit of information about that. Just building up, setting up parentheses, multiplying it all the way out. That's the key to doing this sort of stuff, okay? Last thing that we have to talk about, and we're done. Take about just a quick second here to talk about this in behavior. Of polynomials. A lot of people try to get by just saying, "Oh, I'll just graph it and look what it does." The thing about it is if the numbers are big enough, it's almost impossible to look at the entire graph, because the graph, as the numbers get bigger, the graph gets bigger, right? So you can't really zoom out enough to be able to see the whole picture out of this thing. So if we learn these little short, easy looks at polynomials, it's easy to see what's going on. So if it has an odd degree, and remember, degree is the exponent on the highest exponent in the problem. If it's an odd number, if the leading coefficient is positive, then it's left side down, right side up. Okay. If the leading coefficient is positive. If the leading coefficient is negative, it's the opposite. Left side up, right side down. If it has odd degree. Odd degree, the ends go in opposite directions. That'll help you. Okay, odd degree, ends go in opposite directions. The sign of the leading coefficient tells you left side down, right side up. If it's negative, left side up, right side down. If it's odd degree. If it's even degree, so the highest exponent is an even number, 2, 4, 6, 8, 28, anything like that. And the leading coefficient, the number in front of that term, if it's positive, they're both going to go up. If it's negative, they're both going to go down. All right. Think about even degrees. If it's a squared, it's a parabola shape. Positive leading coefficient, it opens up. Negative leading coefficient, it opens down. That's the way you want to think about that. Evens always go the same direction. If things are even, then everybody's getting the same, right? So that's how I remember even goes the same direction. Positive up, negative down. Okay? Positive up, negative down. If you know that, that'll help you on the, it's easy. You don't have to do any work to the problem. It just asks you, hey, what's the end behavior of this polynomial? You look at the degree and the leading coefficient. That's the only two things you look at. Nothing else matters. Okay? For end behavior of polynomials. That's all that it takes there. All right, so problems that you might want to look at in your textbook. Again, you don't have to do all these. Just give you some practice out of these this polynomial stuff. Again, the graph is going to be your friend. Relate the graph to the polynomial. Do that, you're good. So you got the last labs of the semester will be opened up today. The last quizzes of the semester will be opened up today. Those all are due next week. We will not meet on Thursday, so you've got Thursday to work on those. If you've got questions about those, please email me, and I will try to get back with you. If you got questions on labs or anything like that, email me that, and I'll get back with you as soon as possible. I think, is there anything else? Y'all got any questions for me? Yes, ma'am. In the announcements, the final exam it won't be posted, but the practice final is in the announcements on Canvas. Okay. That's not the final exam. That's the practice final for that. Yeah, that it's the same one. Yeah, but it should be if you go to Canvas and the announcements tab, the one that I sent out last class, the 20th, right down there at the bottom is a link to it there. And you just click that and it'll open up. I said it will. You can download that, print it, work on it. The answer key is at the end. That tells you what the answer should be for each problem for that, so that you can kind of see how you're doing there. The practice final and the actual final are similar in that the problems types are the same, numbers and order and all changes, but as far as the types of problem, it is out of that. I'll link that file again in today's announcement that I put out, and so that you've got that as well, and you'll be able to go from there. All right.